Hello everyone, in this video we're going to be demonstrating how polymorphism and dynamic binding actually works. Now the idea with polymorphism and dynamic binding is we don't actually know the exact type of an object until the program actually runs. We don't know it at compile time. What this means is that when we have some code, the specific method that gets called, say we have two objects that are extend from the same subclass, so they're part of the same hierarchy. Suppose that we have a variable that stores the superclass. However, really what it's storing is the subclass, and the method that we call we don't actually know that until the program runs. Now that sounded a bit confusing, but this video will clear it up really well. So what we're going to do in this video is create a couple of very simple classes. The first one we're going to have is a person. So person. This is going to be our superclass here. Now, from superclass, we're going to have, from the superclass person, we're going to have a class called student. And we're also going to have a graduate student, which extends from student. So this is what our class hierarchy is going to look like. We've got person, which is the base class. We have student, which is a subclass, and then we have a further subclass for grad student. Now, all of these methods are going to have, all of these classes are going to have a toString method. Person is going to have, person's going to have a default toString method, and student is going to override that with its own version. And then finally, grad student isn't going to have its own, it's going to use the one that was in students. Now the idea here is that when we're writing our program, we don't actually know, well, we probably do, but the compiler doesn't know exactly what type of object we're going to have here, whether it's going to be a person, a student, or a grad student. What that means is that if we call the toString method, the actual method that gets called will only be found out at runtime. So this is an example of dynamic binding. Static binding means it's decided at compile time. Dynamic binding means it's decided at runtime. And so with that, why don't we code this up now to see it working? So I've created a new project called dynamic binding, and to this I'm going to add a new class. And what we'll call this is dynamic binding demo. Dynamic binding demo. Oops, no spaces. Alright, now the first thing we're going to do is create our tiny class hierarchy. So first one is going to be person, so class person. And what we're actually going to do here is extends object. Now, we don't necessarily have to do this because by default, every class that we write in Java extends from object. I'm typing this here so it's explicit and we can see that that is exactly what's going on. So public string toString return person. Okay. Next we're going to have our student class. So class student extends person. Public string toString return student. And then finally our graduate student. So class graduate student extends student. And we're not going to have anything in here. It's just going to be an empty class. Alright. So now, inside our dynamic binding demo, we're going to have a method, and we're just going to call this m. So public static void m. Now this is going to take a parameter, and it's just going to be an object. We don't know what type of object. It's just going to be an object, and we'll call this x. And what we're going to do in here is print out the toString method of that object. So system.out.println x.toString. So an object. So that means that we could have any type of object in here, and our method will accept it. And all it has to do is print out the toString method. Now, we're going to have a main method, so public static void main string array args. Now, the first thing we're going to do is have an object variable called O, but we're going to create a new graduate student. Now, we can do this so we haven't actually specified graduate student O equals new graduate student here. We've said we're going to have an object. What this means is that this variable O can store a reference to any object that extends from this here. So if we had person here, that would also work. As long as the object type we're creating is a subclass of what we said the variable was going to store. So having an object here works fine. Next thing we're going to do is have another object, O1 equals new object. So just the base object class. Now, what we're going to do here is see what type of object we actually have. So if O1, now this is a very special keyword in Java. It's called instance of. And then we have a class name. What this is saying is, even though that we're only storing an object, even though our variable type is only an object, we can actually find out the real type of a object that we have here using the instance of method. So what we're going to do here is system.out.println never got here graduate student yes equals, now we're going to typecast graduate student 1. Alright, so the idea here, oops, I've done my cast wrong. The idea here is that this will never be called because the variable O1 is actually storing an object, not a graduate student. If we change this to O, even though the variable O says we're storing an object, we know that what it is actually referencing is a graduate student. So O is an instance of graduate student, so this piece of code would be executed. But for now, let's just leave it for O1. Next thing we're going to do is call the method m with O as a parameter. Now we're going to m new student, m new person, m new object. So we're going to print out the toString methods. So with that, let's run this now once I've fixed my typo. Oops, control save. Alright, and let's see what happens. So run, actually, I'll just bring this back so we can see this. Run as Java application. Okay, so what happened here? Well, the first thing we did was this never got executed because I said it wouldn't, because O1 is an object, not a graduate student. So what we did, we called m on the variable O. Now we've said that the variable here stores an object, although we've assigned actually assigned a graduate student to that. Now what this means is the compiler doesn't know what type of object we're going to have here. It decides at runtime. But because we're actually storing a graduate student here, we call the graduate student's toString method. Now we haven't actually put one into graduate student, which means it inherits it from its superclass, which is student, which is why it printed out student here. We created a student object and called M. Now that printed out student, no surprise there. We created a person and it printed out the person Tostring method. We created an object and it printed out this. This happens to be the default Tostring method for all objects unless we specify our own. So that's what we got here. Now just quickly, I just want to show you something. If we change this to O stores a graduate student, we know that. O is an instance of graduate student, which means this code will execute. So let's see what happens. Run. Uh-oh. Now, never got here printed, which is because O is an instance of graduate student. However, then our program crashed because we tried to typecast O1, which is a type of object, to a graduate student, which it can't do. We can only do this if we know that the type is going to be correct. So that's why our program crashed with a class cast exception. I can speak this morning, I swear. So that's just something to keep in mind what instance of actually does. But if we put that back to how it was, we get some sane output. So really, that's it for this video. So just to summarize now, we created four types of objects. Now each class implemented a Tostring method, and we passed these methods to an object. Now, method accepted an object type as its parameter. The actual type we passed in wasn't known until runtime. So that's what dynamic binding is all about, delaying decisions until the program runs. So with that, that's it for this video. Thanks a lot.